Hey guys, Mr. Gomes here. So we are going to do another limiting reactant problem. Okay, so iron is essential for the production of steel. Thankfully, iron is the fourth most abundant metal found on Earth. Pure iron is obtained by reacting the ore hematite with coke. As manager of a blast furnace, you have 2059 grams of hematite and 2846 grams of coke on hand. So our first task here is to figure out which should I order first. Should I order another shipment of the ore or another shipment of coke? Okay. Well, what we're really looking for there is what's the limiting reactant? What are we going to run out of first, right? Because the one that we run out of first is our limiting reactant, the one that we have to order first. So, just as before, we have 2 grams of A, or grams of our unknown, okay? So we have grams of this and grams of this, and then we can pick our B, okay? We could pick CO2 or just the element iron. I'm going to pick this because the molar mass would be easier to find. Now we can say grams or moles, okay? I'm going to go ahead and say moles just because that requires one less step, and that's less work for me. Why do more work when I don't have to, right? So for number A, I am going to first start with my 2059 grams of iron 3 oxide, and I'm going to do 2 steps to convert it to moles of B. My first step is to use the molar mass of Fe2O3. And then the second step is to use the mole ratio from the equation. So I have 2 moles of this guy. I'm going to put down here. And I have 4 moles of the other one. So grams and grams cancel each other out. Of course, 4 and 2 reduce to just 2. But when I put all of this in the calculator, I should get 25.79 moles of iron. And then for the carbon, or the coke, as they call it in the problem, okay, I have the molar mass of carbon to 1 mole of carbon. And then I'm going to again have the ratio from the equation. I have 3 moles of carbon. And then 4 moles of iron. Again, these cancel out. These cancel out. 2846 divided by 12.01 times 4 divided by 3 should give me 318.0 moles of iron. And I'm rounding all of these based on sig figs. So 4 sig figs here, 4 sig figs here, and the same exact thing with the problem above. So this here makes less product, right? So I'm going to run out of this first. This is going to get completely used up, right? And up until I make 25.79 moles of iron, and then I'm done, okay? So this here is our limiting reactant, okay? This is what we're going to have to get some more of first. All right, now for question B. How many grams of iron can you make with the materials you have? Well, I know I have 25.79 moles of iron. I just got to convert that to grams. I'm going to do 1 mole of iron to 0.85 grams of iron. Moles and moles cancel each other out. I do the math, and I get 1,440 grams of iron. Okay, so this is how much iron we're going to make, and I'm going to put a period here to make that 0 significant, so I can also have 4 sig figs. Remember, the period is your sig fig power as far as zeros are concerned. Add it, make the 0 significant, take it out, make the 0 insignificant, or a placeholder would be a better word rather than insignificant. So there you go. We solved the problem. Fe2O3 is the limiting reactant. We're going to have to order that first. And with what we have on hand, we can make 1440 grams of iron. Okay. Now, you could have gone all the way to grams. If you had gone all the way to grams, obviously for this first part, you would have gotten 1440 grams of iron. And for the second part, you would have gotten 17,650 grams of iron. You still end up with the same thing as the limiting reactant. And then you wouldn't really have to do anything for B because you would have already figured out the answer for letter B. Okay, I just wanted to do one last step. Either way you solve this, you go to the moles of the product or the grams of the product, one step further, you still get the same answer, right? Unless it's asking you for a specific unit, then you have to do that. That's it.